are we going to do for our third century? There's so much on the horizon, so many things under development at McGill University that I hope you think that this is the place that is going to set the initial conditions for an amazing career for you. We want to be future-oriented. We are future-oriented. We want you to be future-oriented, and we think that this is a place to come to take on that perspective. Next slide, please, Savio. So our faculty, the Faculty of Engineering has roughly about 165 professors. We'll probably be at 174 professors by the end of the summer. We have a very, very strong series of undergraduate programs and graduate programs. Our focus tonight is mostly on graduate programs. We have 570 Ph.D. or doctoral students in our programs and 520 master's students, and they're distributed not just across engineering, but also architecture and urban planning. So we have, I guess you'd say, in fact, I know it's the highest intensity of graduate students of any faculty in the university. We are higher than everybody else. But also on top of that, we have the highest intensity of graduate students of any research-based university in the entire country of Canada. So research is a very, very strong focus, but we also retain at our core, our fundamental purpose is the education of students at both the undergraduate and graduate levels. We really have a very strong focus. As I mentioned to you earlier, Montreal is a very culturally diverse place. That's also reflected in the diversity of the students and our student body. For example, 32% of our current graduate students are female, and our female professors comprise about 22% of the faculty members, the professors themselves. 22% is not where I want to be, but the good news is in about the last 6 years, more than 50% of the hires of our new professors have been women, and there's quite a few additional women, more than half that will be coming to us this year. Our new hires are women as well, but we're more diverse than just based on gender, but people of all backgrounds, races from around the entire world. That's really important to us. And in that regard, international students make up 32% of McGill's overall student body, making it one of the most diverse places in Canada. When we see ourselves as an international university, there's a couple of viewpoints I want you to think about that. We bring people internationally. Our representation of our student body is from 180 countries around the world. Those 300,000 people that are alumni are also, though, placed around the world as well. So we invite people internationally to McGill, but we assume that we send people out all over the world itself. And that's why we see ourselves as having a very strong international presence. Of course, students themselves, you want to pursue your education here and set yourself for a really interesting and productive career thereafter. One approach, of course, at the PhD level is that you are expected as part of your work to produce original scholarship, original contributions that advance your field of knowledge. And one metric of that is how much work do we actually get out there published in peer-reviewed articles? So in the preeminent journals, international journals all around the world, we need to publish our work. That's you, as graduate students, are the primary authors of this work. And on average here, full-time McGill professors publish more peer-reviewed articles than any other colleagues at any other Canadian universities. So we not only have the high intensity of graduate students, but the productivity of our research groups is incredibly high, as reflected through the original contributions. Next slide, please, Savio. So just to kind of give you a high-level view of the Faculty of Engineering, yes, we have that name engineering, and it's pretty broad in terms of our basic representation in multiple fields. We have 6 departments of bioengineering, chemical engineering, civil engineering, electrical, computer engineering, mechanical engineering, and mining and materials engineering. Mining and materials engineering are 2 very separate degrees, separate graduate programs, but they're folded under a single department. Under electrical computer engineering, we have electrical, computer, and software engineering as the major undergraduate disciplines to show you the diversity of those units. Department of Bioengineering is the newest department in our faculty. It was established a little over 10 years ago and represents a major shift toward understanding the incredible implications of the biosciences, the life sciences, and all that it has to offer in terms of contributing to the solution of problems that attract the attention of engineers. One thing I never want to forget in our faculty is that we're actually fairly unique in that we have also 2 schools, the Peter Guhafu School of Architecture and the School of Urban Planning. Now, what underlies all of our disciplines is our professions. We are all professional schools, and we all have a very strong focus on design. But what's really important to me as the dean of this faculty is the really interesting and unique perspectives that the schools of architecture and urban planning that bring to our perspectives. I would say architecture and urban planning are firmly seated in the technical and built design world, but also very tightly connected to the social sciences, humanities, civil governance systems, etc. So they bring a unique perspective in our faculty that I incredibly value. It's something that I think that makes us very, very unique, and it's up to you when you come here to take advantage of the richness of all these different disciplines that are in our faculty. Savio, again, please. So with respect to those major units of departments and schools, those are the ones that we orient most of our disciplinary focus around. But we have other structures, structures called institute centers, and there are other related units too that we work very closely with. These other structures house sometimes programs, but very often research programs associated with them. So for example, right now we have 3 major institutes in our faculty, and the institutes can draw their membership from multiple units across the faculty or the university itself. For example, we have the McGill Institute for Advanced Materials. That, again, is a faculty institute, but also co-owned or co-governed with the Faculty of Science. Brings all the strengths of material science into the Faculty of Engineering, but makes a huge amount of resources and knowledge available to all members of the Faculty of Engineering who become formally affiliated with McGill Institute for Advanced Materials. And what you'll find as well for many of our students who are working with those professors, you also become affiliated with that institute and can take advantage of the programs, the opportunities for education, sharing your work, and of course, access to equipment. Similarly, McGill Institute for Aerospace Engineering, that draws about 45 different faculty members, mostly from mechanical engineering, also electrical engineering and materials engineering, but also more recently, civil engineering, chemical engineering people are involved in that directly as well. And this is primarily seated here as a way to focus on interdisciplinary research as it relates to the aerospace field. And Montreal happens to be either the 3rd or now probably the 2nd most intense city for aerospace work in the world. So, for example, I was chairing the board meeting for the McGill Institute for Aerospace Engineering yesterday, and we have representatives from companies like Bombardier, CAE, Pratt & Whitney, these major manufacturers around the table, and they're working very closely with us on our work there. So there's a very, very important linkage with industry, and that leads to opportunities for our undergraduate and graduate students to have placements and also research opportunities embedded within the industries themselves. A 3rd institute is called the Trottier Institute for Sustainability in Engineering and Design. That institute now constitutes about 60 members from across our faculty, plus other members throughout the university and outside the university, with a strong and shared focus on the importance of sustainability as it's implicated in our engineering work, our planning, or our architecture work, but also recognizing that we benefit from collaboration with others. Something that's very new there is we just recently received approval from the Quebec government to now launch our Masters in Sustainability and Engineering Design. That's not directly related perhaps to what you're interested in here, but it actually brings important courses that are already in the books and already being taught that you may want to take advantage of while you're here studying. And that could include involvement of you, wherever your work is, as it intersects with sustainability, which is pretty well everybody, you can learn from and take advantage of the opportunities through that center or through that institute. I won't go through all the centers that are available here. These are just examples of research centers. These have primarily a research focus. Staricom is a very amazing center with a multitude of researchers from across the province, mostly province of Quebec, and industry representatives in the information technology area. The Center for Intelligent Machines, which is about robotics, applied artificial intelligence, co-owned with the Department of Computer Science, the Faculty of Science. It's the oldest center that we have currently at McGill University, has a rich history, but really an amazingly important, placement, I guess you'd say, in the history of artificial intelligent robotics, which are really taking off at this point, especially here in Montreal, which has an amazingly strong AI focus. The Bray Center for Water Resources Management mobilizes researchers on water-related issues. The Plasma Technology Research Center, primarily out of chemical engineering, involves people who do plasma research. You're going to think this one's funny. The Yan P. Lin Center for the Study of Freedom and Global Orders in the Ancient and Modern World. And you're probably saying, what is that doing in the Faculty of Engineering? Well, this is a unique center. It's a partnership between engineering and arts, and it's designed specifically to create conversations, dialogue between East and West cultures, between modernity and antiquity, but also between technology and humanities as well. So it's a vehicle for direct collaboration, intersection with the humanities and social sciences, which brings important added value to our faculty. Our newest center is the McGill Center for Innovation and Storage and Conversion of Energy, which with a major donation, a $2 million donation that we received a couple of years ago, we have now kicked off this center with essentially the main focus on alternative energies and, of course, the storage systems, whether it's chemical batteries and other approaches that are used that really are kind of pivotal to the movement toward renewable energy. And lastly, I just want to mention, and sometimes this creates some confusion, we have a Department of Bioresource Engineering, but they're not under the Faculty of Engineering. They're under the Faculty of Agriculture and Environmental Sciences. We do have very tight liaison with them, and you certainly can take advantage of all the services, courses, and other things that they offer there. But I just want to clarify where they're located. They came out of an agricultural focus, but they're more broadly focused on natural resources at this point. But they are distinct, but they still have a tight relationship with us. Similarly, we have a Department of Biomedical Engineering that is under the Faculty of Medicine. They are a separate department. They have only graduate programs, no undergraduate program, but they have an incredibly tight relationship with us because our Department of Bioengineering shares a graduate program with the Department of Biomedical Engineering. So if you're coming into our, let's say, our Department of Bioengineering under one of our professors, you would earn a degree in biomedical and biological engineering as your degree program, and you'll find yourself immersed in an environment of students from the program in the Faculty of Medicine. And finally, the School of Computer Science, which actually originated in our Faculty of Engineering. Many years ago, it was very heavily focused on programming, or computer programming. But as years gone by, what happened is that the theoretical basis for computer science got stronger and stronger, particularly as it relates to information studies. And so at one point it moved out into the Faculty of Science. That being said, they have a very tight affiliation with us, so you can imagine on issues related to machine learning and other aspects where there's a direct collaboration between us in all our disciplines with what happens in computer science. Next slide, please, Savio. So, our purpose here is really to prepare you, as I often said, for when it comes to engineers. Engineers often know, of course, about the importance of initial conditions. So we're setting you up, we think, for the initial conditions that when you leave this university, you are set on a trajectory to an amazing, very fulfilling and challenging career. So the idea that the kind of the working premise I start from is that our goal is to prepare globally minded professionals who are equipped to solve the problems that matter. There's a couple of main thrusts I want to draw attention to. Globally minded means that we want people who have not just are experts in their own domain, but have the big picture in mind, which is really, really important. If you want to make effective solutions to some of the world's most pressing problems, you need to have the big picture in mind as you undertake your work. But similarly, we want to equip you, and to equip you both with the basic knowledge and education, building on your undergraduate or prior degrees that you come to us with, but to equip you with a new set of knowledge and skills, equipment, whatever it may be, that help you solve a class of problems perhaps that have never been tackled before. So we equip you with knowledge, techniques, capability, networks, etc., that will make a difference over the long term in your career. And the last focus is to solve the problems that matter. There's enough huge problems that are out there in the world today that need a lot of attention. I don't think that there's anybody better than the professions of engineering, architecture, and urban planning to really dig into the deep problems that most impact humanity. And we want you to do that. We want you to focus on your research, not just for the purpose of conducting the research itself, and not only with the goal of getting your degree, but to allow you, through your work, through your studies, to have a huge impact on the big problems that matter around the world. If you can do that right from the start, you're going to set yourself up for an amazing career over the long term. And what that means is, from a perspective of our research, we're really trying to explore the path of future discovery with the idea of knowledge creation, which is incredibly important, especially from a PhD perspective, original contributions to knowledge, but also with transfer of that knowledge, to put that knowledge into action. And of course, our focus in engineering is not to be the creators of all knowledge, but to really focus on technology in the built world, which underlines those professions of engineering, architecture, and planning. And overall, if we're going to do this work, we have to do it effectively. It has to be done in a socially responsible way. We want innovations, ultimately, that by design, at their very core, at the very start, are all about enhancing prosperity for society at large. That is, if you can reflect on your work and guide your work with these larger outcomes and goals in mind, again, I'm going to guarantee you that this will lead to an incredibly productive and very fulfilling career path over the long term. Next slide, please, Savio. So what we are always striving to do is to be a world leader in our academic and industry research. And that means about strategically investing in a whole bunch of issues where we have the critical mass and expertise to make a difference in the world. This work does not happen without research funding. So we work very hard at bringing through government grants, industry contracts, partnerships, and even philanthropy. A lot of our alumni give generously back to us. And in fact, they have actually made it possible for us to support the McGill Engineering Doctoral Program, which we'll talk more about later. It's critical to us that we really diversify the research portfolio by really setting the stage so that all our people, our professors, our students, everybody who's involved in our work can work on a whole series of classes of problems where their expertise can be brought to bear. And by doing that, we can have a cumulative major impact on the world. Another thing is to use our resources very efficiently. So we develop and implement shared facilities to support large-scale and collaborative research. This is not about you only taking advantage of the resources that are in your immediate laboratory, maybe under the supervision of your supervisor that you're working with, but to give you access to shared facilities in your unit, in the faculty, and in the university, and through the partnerships, our network of other universities, businesses, etc. And of course, we always want to make sure that our graduate programs are at the leading edge, which means about always making sure that we're giving you the experience that you deserve and that you need to set yourself up well on your career trajectory. Next slide, please. So you can't do all things and be all things to all people. So I mentioned to you earlier some of the institutes that we've created in the department, the new Department of Bioengineering. Those came out of decisions that we made to say that there are key areas where we want to invest a lot of our resources, our time, and attract our students in. Now, we want to bring in our students and our professors in all our basic areas. That still remains the same. But there are places where we see as huge opportunities for the Faculty of Engineering, particularly as it relates to the context within which we find ourselves, that is McGill University, but also Montreal, Canada, and the rest of the world. So our 5 main thrusts of our work in the past years has been bioengineering, to really liberate or take advantage, if you want, of all the developments in the biosciences, the life sciences, to really mobilize this new knowledge to actually bring it to bear on a class of whole new problems. You can see the potential of this area as reflected through, for example, what we just came through in terms of the pandemic, and in terms of, let's say, the generation of a whole new generation of vaccines. The potential of mRNA vaccines, but also the associated processes of biomanufacturing, et cetera, is so huge that this is an area that we're continuing to grow, and keep watch for some major announcements, probably in the next month or so, for some initiatives that have just received government approval, major financing and support. Likewise, aerospace engineering, we again find ourselves in one of the most aerospace intensive cities in the entire world. We have all these incredible major manufacturers of aerospace in the area. For example, one of the vice presidents of Bombardier Aerospace was with us yesterday and said they're looking for 400 new people to enter into their programs, including researchers, leading researchers in aerospace. Similarly, we heard from the vice president of Airbus, one of our graduates from years ago. They'll be looking for 700 people in Montreal area just alone to support the aerospace industry. So you can see why we invest very importantly in this really strategically important area. Similarly, information communication technologies, I mentioned to you earlier, the Center for Intelligent Machines, certainly the major advances in machine learning, artificial intelligence, particularly with our focus, which is applied artificial intelligence, is really key. And that's embedded in a larger AI ecosystem here in Montreal, which has been built up over the last few years. I mentioned engineering and design for sustainability through our Trotsky Institute that we've established here. This has become core to our mission, as exemplified by the fact that more than 60 of our professors are directly affiliated with this institute, which shows you how sustainability is essentially integrated in pretty well all our programs across the faculty. And then advanced materials and nanotechnology, also emphasized through our developments in the McGill Institute for Advanced Materials, but also dramatic importance in terms of mechanical engineering and electrical engineering, materials engineering, chemical engineering, et cetera, bioengineering in the whole range of materials applications that we see there. So you'll see a lot of developments in these areas, I think, in the coming years, and you'll see, in fact, the already strong presence of those areas in everything we do at this point. Next slide, please, Savio. So our goal, in a sense, our people are our major resource, and that includes our professors and, of course, our students. So our goal, working with our professors right now, there's a whole bunch of different points that we're working on, but certainly always to be at the top end of leadership in terms of research and education. And a lot of you who are coming here for a PhD may actually be thinking about an academic career. And so you should not define your experience totally around what you do in your laboratory, your original contributions to research, but you should start thinking about what it means to be a teacher, an instructor, and what it means to be a professor. And there are opportunities for you to round yourself out in terms of advanced approaches, modern approaches to education. And you, as, for example, teaching assistants, might be able to get directly involved in some of those activities. We're always about bringing the best and brightest from around the world to recruit and support best-in-class professors. And of course, we ought to make sure that we have a very diverse group of professors from around the world who are working not only with each other, but with students from everywhere around the world as well. We support our professors with awards through these, what we call chairs. The chairs can be endowed through philanthropy to support strategically important areas, but also major external awards that we nominate our professors for to secure research funds. And the majority of those funds flow into the hands of our graduate students, who are, again, the main source of all of our work. We are also always trying to explore new ideas. So we have various funds that are available to seed new research ideas to determine about whether they have viability, whether they're feasible, and whether they can lead to new opportunities for other research grants, sources of funding, et cetera. And really importantly to us, particularly in the Faculty of Engineering, is to support research translation. It's incredibly important to get original scholarship out the door, add to the literature out there in the international peer-reviewed literature and journals, things like that, conferences. But it's equally important to translate that into practice in the form of commercialization, through patents, through licensing of our technologies, and of course, startups, which I'll express a little bit more about that in a few moments. Next slide, please, Savio. I won't go through these, but these are just a small sample of incredibly diverse group of people who are all in the leading edge of their fields. And I got to say that I'm just incredibly amazed at the productivity and the originality of our people. And your goal is not only to work with a single professor, but to take advantage of the incredibly rich environment you find yourself in, taking courses with other professors, involving other professors potentially in your work as co-supervisors. You'll find yourselves embedded in teams, etc. Next slide, please, Savio. So your experience, we hope, involves, if you take advantage of it, and I'm going to throw this, it's not about us producing everything for you. It's about inviting you into a highly interdisciplinary research environment with all kinds of opportunities for educational exposure through the courses, the programs, and through the people that you meet. So you will find yourself at McGill University in an amazingly rich place in the Faculty of Engineering, but you must not forget that you are embedded in a university with incredible scholars and students from around the world in a whole diverse array of incredibly powerful disciplines. We want you to take advantage of that while you're here. We're always trying to do to stay competitive on the research funding side, just to make sure that the funding not only to support you, but to support the research at the highest possible level. That's something that we work on day to day in all our work. Our goal is to innovate together, and what that means is take advantage of each other's thought processes, backgrounds, experiences, to challenge each other to produce new and original scholarship. That means, again, not working alone, but doing whatever you can to interact with others, which will actually lead to improvement or kind of amplification of your own ideas, testing your ideas and make them more effective. And of course, your ideas will result only in innovation if we translate them. And so a key issue for us is to help you not only developing the knowledge, transferring that knowledge, one, in the form of scholarship through peer-reviewed journal articles, through conference presentations and the like, but transfer to industry so they can take it up there, and also to explore the opportunities of entrepreneurship. Next slide please, Savio. So to round out the overall experience in our faculty, we try to provide a whole range of opportunities for you. We'll go through these in detail, but we have 4 initiatives called Empower, eIdea, Elate, and Engine, which I want you to take a look at, but it's really about providing you opportunities to gain other experiences that complement the work that you're doing. I'm going to focus a little bit most on most of this about Engine, but just to say Empower is about giving you and all our students the opportunity through experiential learning to push the boundaries on who you are as a person, as a professional. eIdea is really focused on inclusivity, diversity, and equity advancement, not only in terms of the demographics of who is here at McGill University, but to challenge you to bring an EDI perspective to the work that you undertake in your research as appropriate. Elate is about changing the nature of the teaching that we do, putting the students at the center of the learning. And you, as students, will experience this, but also as teaching assistants, if that's what you choose to do, can get embedded directly in a community that is focused on enhancing the learning experience of all students. And now I'll move on to Engine. Next slide, please, Savio. So the McGill Engine Center, I just want to plant this idea early on. Engine is about, the Engine stands for engineering, innovation, and entrepreneurship. It's about taking your ideas and putting them into practice. It's about you taking a look at your research early on and deciding who the clientele is that will take advantage of your original contributions to knowledge, and using that perspective to explore opportunities for the translation of that work. Now, that could take the form of you being at the leading edge of your, say, technology. You can then transfer into that industry and seek employment there. And of course, that's a form of knowledge personnel transfer that we're looking for. Other forms, though, it can take is that you develop intellectual property that you can actually have license for use by many other industries in their day-to-day work, which is really important because that's a form of uptake of your knowledge. And the other side is that you can actually consider being the founder of a company. Our Engine Center has now founded 70 companies in the last 6 years, 70 companies. Now, companies fail, so 45 of those are still alive, but I'll give you an example of one. The speaker just came here to talk to us last week. It was one of our student ventures that ultimately ended up in developing first an electric snowmobile and now electric Sea-Doos, the watercraft that you see out there, fully battery operated. They secured over $650 million in funding in the last 6 years in their work, and they're building a major manufacturing plant to put all their products in the market this year. So it's really quite incredible. And that came from ideas that came from our laboratories, and then with the right support, financial, personnel, et cetera, and then linking people up to mentors, people out in the entrepreneurial sector to help you understand how to protect your intellectual property and then how to capitalize on it, how to find venture capital, who are people who are willing to invest in your work, etc. I want you to really think about this very carefully and take advantage of the services, the workshops, everything that we have to offer. And it includes financial awards to you to help you maybe develop a prototype of your work that makes it ready to be taken up by an industry partner. I spent way too much time on my presentation. I think it's time for me to hand it over to Associate Dean Ann Kietzig there. But I hope you get really excited about the prospect of coming to McGill University, and I hope that we're going to greet you here in the coming fall term. So thanks for your attention today. Ann, over to you.
Well, thank you, Jim. Yes, so Sally, next slide, please. I'm Kietzig. I'm, well, the Associate Dean, as just mentioned, and I'm a professor in chemical engineering. So I saw that some of you will do a PhD in chemical engineering, so we will see each other's here on the floor. I will tell you a bit more about the, well, financial support system that we have here for doctoral students. And well, because you're here, you probably received an offer letter from the McGill Engineering Doctoral Awards program. So that there's different types of those so-called MEDA awards. And the first one that's detailed here is the domestic MEDA, which is valued at $24,000 per year. This comes to you as a stipend, so it's not taxed. And you ensured that funding for 3 consecutive academic years. So this is specifically for domestic students, and you don't have to do anything for that. You basically, during the application process, were already considered as potential candidates. If now, moving forward, as you might have seen from your offer letters, you apply for another external scholarship and you actually win that, you, I'm at the meta leverage case. If you actually win an external scholarship, and then you will get not only, well, you will basically end up with more than a 24,000 base case because you will receive a top up. And so now we move to the next slide, please, Savio. The situation for the MEDA International and the MEDA International Leveraged is basically the same. However, the base funding rate is different because international students pay higher international tuition fees. So the International Doctoral Award is at 37,000 over 3 consecutive years. Same process for nomination has already been completed for the May and the September well, intake. And again, if you apply for an extra external scholarship and you actually win that, maybe this year, maybe in following years, then you will earn a leveraged award, meaning that you will be guaranteed a top up of $5,000. So it's worthwhile looking into those other funding opportunities. Some of you might have or might come in with a MEDA International Ph.D. 1. That is specifically for international students that receive $37,000 per year for 3 academic years, and then in a 4th year, $27,000. So it makes a total value of $138 over 4 years. It's a guaranteed funding package over 4 years. Why is there a drop in the 4th year? Because the international tuition does not apply in the 4th year of PhD studies. So even if you have any other award and you're an international student and you are here for longer than 3 years, your tuition payments will drop after the 3rd year to the level of domestic students. And therefore the funding here drops too, because you don't need to be compensated anymore for international tuition. Savio, next slide, please. So some more details about these MEDA awards. They are cost shared by the supervisor or the department and the faculty of engineering. And on the side from the supervisor, typically the funding comes from research grants, from particular projects, from government funding, with or without industrial partners. And then the faculty portion comes from prestigious named fellowships from donors. So in the future, if you accept one of those fellowships, you might be asked to write a little report, a little thank you letter to the particular donor, to whom we're very grateful, because only these donations make those funding programs possible. If during your tenure of one of these awards, you obtain an external award, you don't only get a top up, but you also have to tell us that you got an external award, because we might not know if from your home country or somewhere else you actually received external funding. Similarly, if you become a permanent resident or you take up employment, you also have to declare that to the Faculty of Engineering. And the typical requirement is that you do so within 10 days so that we can adapt the funding scheme. Now, your MEDA stipends will come with funding per year, as I just mentioned, but there's one particularity. For students that start in September, the stipend will be paid out over 8 months. That often leads to confusion because even though it's the value for an entire year, you might be very happy because bi-weekly you receive more money than you actually expected. However, that means that come May 1st, you will not receive any more money until the next September. So keep that in mind because you want to manage your finances well. If, however, you start in May, you don't have to worry about that because the financial year also starts in May. And so there is not that particular 8 months rule. In addition to this funding package, there's the opportunity to have additional teaching or research assistantships. So especially teaching assistantships are a great opportunity to not only hone your teaching skills, practice presentation skills, but also gain expertise or deeper expertise in specific subject matters that you might have heard in your undergrads, but they might have been forgotten a little bit, or they might be taught differently here than from where you're coming. So sometimes these opportunities provide additional teaching and learning experiences at the same time. Next slide, please. So the couple that you see here on that picture are Les and Judy Vadas, and these are our most prominent donors that have established a Vadas Fellowship, which is particularly for domestic students, so meaning Canadian citizens, Quebec residents, and permanent residents. It comes with $32,000 per year, and it's a funding package over 4 years. Again, some of you might have been nominated for that, and this is a very prestigious fellowship, and we're very, very grateful that we can offer that opportunity to some of our domestic students. Next slide, please. So another specific fellowship is the so-called IBET Momentum Fellowship. IBET stands for Indigenous and Black Engineering Technology Momentum Fellowship. So if you identify with one of those minority groups, you might be eligible for additional funding. And this funding package comes with $30,000 guaranteed over 4 years for the McGill recipients. Here's the link to the website where you find further information. If you can also simply Google IBET McGill and you will drop directly onto the respective website. Next slide, please, Savio. So aside from the core funding, which is there to support tuition expenses and living expenses, there are several opportunities for travel funding. And there's the Great Award. That might be the most obvious one. We want you to go out and present your work at conferences, and we want you to take opportunities for research enhancement activities. That might be participation in a workshop, that might be exchanges with other research collaborators. And this is the so-called Great Award that you can apply for, and where there's some money reserved for it. Differently, a bit bigger in the volume, are Graduate Mobility Awards. So these are for students that want to study abroad or specifically conduct research abroad. So if you have an interest that is even within your own research topic or maybe outside your research topic, and you find a lab to host you, or your supervisor has collaborators somewhere abroad, and you want to spend some time there, and that means several months to do other experiments that maybe you can't do here or gain other experiences, then that is an award that is really specific for such opportunities. And finally, we have the Graduate Research Traineeship, but this is maybe more for students that come in for a short period of time. So you might see in your lab group students that are here for up to 12 months, but that come from another university. And for those, this award is reserved. Next, please. So in your MEDA offer letters, you've probably already read it, but you have to accept the MEDA offer, if you want to take it, by April 15th. And you have to return that MEDA offer letter to the here stated email address, Graduate Studies Engineering. Whereas at the same time, or before or after, but also within the deadline, you have to also accept your PhD admission via slide on the online platform. So make sure that you don't only accept one of the two, you have to accept the two if you want to benefit from both. And then funding will be available for you basically by the semester by which you wanted to start your graduate journey. The next slide, please. So in the following, I want to give you a few more details about what it means to study in Montreal. And Dean Nicell has already mentioned several of the facts that are listed here. I think one of the biggest bonuses of Montreal is that we have very affordable cost of living. And especially in comparison to other countries like the US or the UK. We have a very high quality of life and student life. Montreal is a student city, and you'll see more about that on one of the next slides. But we also, within McGill, thank you. Within McGill, we have the Postgraduate Student Society, which is a society of graduate students that offers sources of support. And that might be, for example, French courses. Might also be support for social activities and events if you have ideas to make an event yourself, or if you would just simply want to connect with other students about a certain topic, are interested in certain activities. They maintain a pub, which is actually really nice pub. It's Thompson House, where we as professors also like to go, but we only can go there in the company of graduate students. So it's a student-run pub. It's nice to have lunch. It's nice to go out for a beer, and it basically provides the ability to meet other graduate students from other faculties, other disciplines over a drink. And then there are the department-specific student associations. Typically, every department has a graduate student organization that might, for example, offer movie nights, pizza lunches. So there's a possibility, an easy possibility to meet with other like-minded people beyond your core research. And I encourage you to participate in those opportunities, because sometimes you might meet someone from completely different field, completely different research discipline, but suddenly 1 year down the road, you might need a piece of equipment that you know happens to exist in the lab of one of those other people, aside from the fact that you simply might make very good friends. So with respect to post-graduation, you might already know that upon completion of your graduate degree, Canada offers a post-graduation work permit for international students that graduated from a Canadian university. So this is a great opportunity to either explore more of Canada or stay around in Montreal. And as the last bullet point states clearly, with respect to employability survey, McGill has ranked 29th in the world. So with that, I want to share a few more statistics with you. Montreal, among the cities in the Americas, Montreal is Canada's university capital. It's tied with Boston, and it ranks before Toronto, New York, Vancouver, or San Francisco. You can see from the numbers here, 320,000 post-secondary students live in the city. You will not be surprised to see many young students crossing the streets and around on the streets. 200,000 university students with 35,500 international university students are here in Montreal. Also, we from Canada for university research funding, as was previously mentioned. Next slide, please. So the low cost of living is here shown in a statistic. And well, we're proud and very happy that in spite of the recent, financial changes and inflation and the like, we still rank as a city with very affordable living costs. Now, cheap housing, there's low medical insurance costs. The government offers very generous family allowances, and out of own experience, I can confirm that childcare is affordable and very accessible. So Greater Montreal is cheaper than almost all other large cities in North America, Western Europe, China, and Japan. And that definitely is a great plus for graduate students coming here. Next slide, please. So when we talk about life after graduation, there's a big interest in the fact that in Montreal, we have the highest concentration of tech jobs in Canada. So we have 70% more than the Canadian average, which is astonishing and amazing. But you've just heard from the Nicell that not only Bombardier at Airbus in the aerospace industry, but also the AI or IT sector are very active in Montreal. And therefore, it's relatively easy to find employment and stay in Montreal if you're interested to do so. Next slide, please. So finally, why pursue graduate studies in McGill's Faculty of Engineering? I just want to sum up everything that has already been mentioned. Well, there's a diverse faculty, and only do we have high caliber and engaged graduate students, but we also have professors that come from all over the world. World-class research is carried out here. That's what you've seen from the university rankings. McGill Engineering is one of the top engineering schools. We have a strong community within the faculty and also with our research centers and institutes, as outlined previously. And those institutes and those research centers really foster the interdisciplinary research that is being carried out here, because those research centers are made up of professors from all different departments, even different faculties. So, as mentioned earlier, if you're a student of a professor who participates in one of those centers, you automatically take part in that as well. And so you will be able to meet like-minded people from biology or physics or architecture, whatever you can think of, what might be relevant to those particular research centers. This also gives an opportunity to work on cutting-edge issues that are of concern and doing research in a field that is fast developing. And then finally, as I just highlighted to you, Montreal is a vibrant city. It has a safe campus. The campus is in the middle of downtown, so it's very easily accessible. But at the same time, we have, like it's right here behind me, we have the mountain. We have a big park in the center of the city. So if you want to go for a stroll during the day, that is basically a few minutes away and very accessible. So I think with that, I want to end my part of the presentation and therewith, I guess, the presentation completely. So here again is the link to the Faculty of Engineering website, as well as the email address that you probably already know. And I've been seeing the chat popping, but I was not able to present it at the same time. Keep track of all questions.
We've been answering quite a few of them, but there's just, I know we're just about out of time, but for those who can stick with us for a few minutes, we'll be happy to answer these questions. So one of the questions that I didn't answer yet was about the length of a PhD program, how long they typically are, and what happens when that MEDA funding ends after the 3 years. What do students do to be funded or to help pay for fees and living expenses after 3 years?
So that is a very good question. Unfortunately, our present funding packages only cover 3 years, but that is the guaranteed funding. Reality is that most PhD students take more than 3 years to complete their studies. And also fact is that most often supervisors find and fund their students for at least another consecutive year. Mm-hmm. That might become different if you're in your 6th year of PhD studies or aiming towards the 7th year. But typically there's not a concern about the funding in a 4th year. Because the typical duration of a PhD is longer than 3 years. However, keep in mind that this guaranteed funding is for 3 years.
I think just to add to that, I think it's important for you to have that conversation with your supervisor. In my case, all my PhD students, I maintain at the same level of funding in their fourth years that they had in the previous years, and I think that's a tradition for most. It might vary again for international students when your tuition drops substantially in the fourth year. There might be some adjustment, but I think it's worthwhile having that conversation because I think it's important that you enter into a relationship with your supervisor knowing the terms. But of course, funding isn't infinite. So as Professor Kietzig mentioned, when if your research is taking very long, there might be a point where the professor is unable to support you any further. So I really strongly suggest you have that conversation with your supervisor.
So another question that is being asked is, are full-time internships allowed during summer breaks? Now, I know typically PhD students are pursuing their research during the summer, but I don't know if either of you, Anne or Jim, as supervisors want to speak to that.
So basically, there is no such thing as a summer break. When you engage in PhD studies, then this is year-round. Particularly during your first semesters, you might take more courses, and the courses are only often only offered during the fall and the winter semester. But that means that during the summer, you will spend your entire time in the lab and actually conduct your research, prepare for your preliminary examination, write papers, submit those papers, deal with the reviews that you get. So the question whether full-time internships are allowed during the summer break, therefore, well, my first response is there is no summer break. The second response is that we have internship programs in the sense that if your research supervisor has a particular research grant, and those are called MITACs, if you're familiar with that or you want to look at that, these provide opportunities for research students within their field of research and with the support of their supervisor, and this is very important, to tie an industrial experience into their graduate studies. And in these cases, very often the student might go off to a company and actually work there for 50% of the time of an internship. That's typically a 50-50 split. And however, during that internship, yes, get an insight into what that company is actually doing, but still conduct research in the direction towards the degree. Jim, do you want to add anything to that? Did I cover everything?
I think you covered that very well. I'm just adding a link to the MITACs program. You can take a look and see the opportunities available to students. Again, if a professor has a tight relationship through the course of your research, you may find yourself embedded in an industry environment for a period of time. That's all dependent on a MITACs grant. And there are a whole variety of different types of grants that you can take advantage of. So that's one alternative. But I will say that just to echo what Professor Kietzig mentioned, a PhD is an intensive research enterprise. When you're through your courses and maybe you don't have any teaching assistant activities, the summertime is actually the most productive time of all for research. And it's where your professors are not teaching anymore, so it becomes a very, very active period. This doesn't mean you don't get a break. You do get a break. You're entitled to time off, and you have to take time off for your own health. But the summers keep going. It's not like undergraduate education at all.
Another question that I think other people might be wondering about is about applying for teaching or research assistantships. So how students go about becoming a TA.
So TA-ships are typically, typically a student that is already enrolled at McGill will receive an email towards the end of the present semester or during the summer semester, asking for TA-ship applications, and then you apply. You mention the courses that you would like to TA, but it might be that due to union rules, because TAs are unionized, you might not get a TA-ship in your first semester or even in your second semester. It depends on the department in which you study and in which you apply. I can personally comment on chemical engineering that PhD students from their second semester onwards typically get a TA-ship. Not everybody wants one, but it's not guaranteed that you absolutely get the course that you're dreaming of. And then when you're given the choice of courses that would be available to you, you can still say, oh no, I don't want that course because that doesn't interest me. So that opportunity still remains.
Thank you. What else do we have here? If I need to take 1 or 2 courses, when should I take these? Is this something that's better discussed with a supervisor to discuss timeline, or do you have a general rule of thumb for that?
Well, I'd say in most programs, if you're going to take courses, they're usually at the start of your program. They kind of set the foundation for your work. One of the first milestones, deliverables that you'll have to undertake is a comprehensive exam, which is essentially to it's essentially an oral presentation of your planned research in front of a committee of professors. And as part of it, there can be a comprehensive exam, which is kind of basic questions that flow from your background preparation. And as part of that, what a lot of students will end up doing in certain programs is take a group of courses that will help solidify their background in their particular area. A lot of PhD programs have no course requirements whatsoever, but you might wish to get some of those courses behind you to help you advance your research appropriately. So, and by the way, one other thing that can happen is at a comprehensive exam, if the committee feels that you could use a bit more training in a particular area related to your research, they might strongly recommend that you take a course after that to give you that. That happens once in a while.
Thank you. I think the only other question that hasn't been answered, oh, there's another one. Are we going to receive RA when we are doing our research in the lab with our supervisor? I think that's tied in.
And do you want to take this one?
Actually, I am not entirely sure on the answer here, because typically you might be working on an additional, like you might do your core research in your supervisor's lab, and then your supervisor might have a little side project for which he or she will pay you extra. And that, however, comes up in that moment with your particular expertise.
Yeah.
So it's not that there is, you know, a long list of RA ships, because if we get projects that require one particular skill, then I will ask my graduate student who is most proficient in that to help out. I think this is how it's typically done. Maybe Jim, you can comment further on that.
Yeah, I think what often happens is confusion over the kind of support you would get through the doctoral award program and the professor support, which is effectively an award for you to pursue your studies. So that's your financial support to enable you to pursue those studies. A research assistantship is more like an employment opportunity, and it's not usually embedded directly in your studies itself. So as Professor Kietzig was mentioning, that might happen occasionally if you want to get involved either in a, you know, almost a contractual relationship with short-term deliverables on a project that your professor is working on, or I've seen other cases, my graduate students have gone on to work for another professor for a month or two to work on some specific project, but it isn't directly related to your PhD program. So those are the kind of things that will come up possibly for you, but it's not generally the approach that most students would take.
Do we have any other questions? If anybody wants to verbally ask, that's fine as well. I know we're 10 minutes over the time we had scheduled, so thank you everybody for bearing with us.
You're okay?
Anybody?
If
not, I want to thank Dean Nicell and Associate Dean Kietzig for presenting to us this evening, and thank you all for joining us. If you do have any additional questions, please feel free to reach out to us at graduatestudies.engineering@mcgill.ca, and we will get back to you as soon as we can. We look forward to seeing you in the fall. Thank you very much.
Thanks, everybody.
Thank you. Have a good day.